So good morning, everyone. My name is Deirdre Denman, and I'm the marketing coordinator at EandM. Thank you for attending our Learn in 30 webinar on PROFINET push buttons. After the webinar, we're going to be doing a short Q&A, so please type any questions or comments you have into the Q&A box, the chat box, or you can email us at webinars@eandm.com. I'd like to introduce your presenter for this morning, Mark Berger with Siemens Industry, to get us started. Good morning, Mark.
Good morning, everyone. Excited to be with you, and thank you for taking time out of your busy schedules to be with us. I'm excited to cover this topic today. This is for our SIRIUS ACT PROFINET push buttons. Just a quick introduction of who I am. My name is Mark Berger, and we've been with Siemens for almost 15 years. I'm with the Smart Infrastructure Electrical Products Group. I am an application consultant, an application resource center. The ARC team is what they call us. There's 4 of us that cover the United States. You have your general salesperson with Siemens, and then you have a product consultant. And I assist the product consultants with proof of concepts, soft starters, safety relays, PROFINET push buttons, like our topic today. We go with Simicode and motor management, and then proof of concepts with controls products. Prior to that, I was controls and instrumentation engineer for quite a few years. So today we're going to talk about the SIRIUS ACT PROFINET push buttons. It's an integrated technology. It's very easy to install. Understand that this is our 22 millimeter push buttons or actuators. And everything is standard minus the terminal block that you put on the back. So if you have an established system now that you've just have the traditional wiring with terminal blocks, and you would like to use some of the systems and the advantages of PROFINET push buttons, all we would do is we'd leave all the actuators in place and we'd just change out the terminal block in the back. It does reduce wiring. Reduces your inputs and output cards. And again, it's universal to our SIRIUS ACT devices. So the benefits of it is the communications and flexibility. It does reduce wiring significantly. It's very flexible. Again, the modification of this as quickly is that the actuators are all exactly the same of our standard push button line. There's no extra part number or something you need to add, other than you just change the terminal block part number. We do have, it comes with an e-stop. So we do have PROFISAFE with this communication over Profibus. Here's the 2 flavors of it. The initial one is the standard interface module here. That interface module is what you plug in the PROFINET Ethernet cable into, and then you run the 24 volts to. And then from the interface module, you go to a terminal module. And from the terminal module is your push button or light indicator, or a combination of push and LED light. You can go up to 20 max. We can do 20 terminal modules. In between each terminal module, that ribbon can go up to 1 meter. And from the interface module to the very last terminal module is 10 meters. Here's the, oops, oh goodness. Here's the PROFINET with PROFISAFE, the PROFISAFE version. We do have an e-stop that we can put on it, plug in with the Ethernet cable. It does have to work in conjunction with a safety PLC. And this e-stop here, then again, ribbon cable, so forth and so on. So to reiterate, 10 meters from the interface module to the last terminal module, and then 1 meter between each terminal module, and that's the maximum. Here's a review of the part numbers. The interface module for safety is here. In addition, you can, with this interface module, you have 4 digital inputs, 1 digital out, 1 analog in, and also a 10-volt power supply that's not listed here. So what that means is in addition to the 20 push buttons that you can add to it, You can have 4 more standard wired push buttons, a digital out, and then an analog in. This analog in can be a potentiometer that does 0 to 1,000 counts for like a speed reference or a VFD or something. And that's all hardwired in the back of the interface module. Then here's the standard interface module. And it also there's 2 part numbers for it. One that does not have the additional I/O, or one that does. And you again can hardwire that in. I have this one today. This is the one that I'll demonstrate today, is the standard interface module. The terminal modules come in 3 styles. One is command only. So it's 2 mechanical signals, 2 mechanical contactor closing, left and right. Next one is a command with the 2 mechanical signals and mechanical contactors, and then with an LED, and then you just change this number here for what color you would like the LED to look like. And then last is just a standard LED module. And then here's the part number that you change for that color. In addition, there is a memory module. So for some reason that the interface module has to be replaced, you would remove this memory module out and plug it into the new one, and all the settings would be transferred over to the new interface module. Then there's an LED that goes into the interface module. So if you wanted an illuminated e-stop or an illuminated selector switch, you would use this LED here versus the terminal modules with the LEDs. Then there's the ribbon cable that you use to communicate from the interface module to the terminal module. Comes in lengths of 5 meter and 10 meter. So with just a quick comparison, here is 2 decentralized panels. One, control panel number 1 is the standard hardwired version, and then control panel number 2 is the PROFINET version. Notice the front of them, you couldn't tell any difference. Again, because all the actuators are just our standard actuation, and the only difference is the communication terminal blocks on the back, or the standard hardwire terminal blocks on the back. So we do have a potentiometer in here, we have an e-stop, and then you see the actuators of LED indicators and push buttons. We open up the cabinets and look in the back. You can see here's just your standard wiring, hardwiring it with your terminal blocks. Notice the guy in the center there, that's your LED only indicators. Then you have a combination of LEDs and normally closed or normally open contacts, so forth. And then on the right hand side is the PROFINET push button version of that same panel. Notice that the wiring goes from the bundle that's transmitting from coming from the front panel of it, crossing the hinge and going into the box, goes from that big bundle of wire down to your RJ45 cable, and then 24 volts. That's it that comes across. Everything else is on the door. Notice the ribbon cable is daisy chained. Here's the potentiometer I spoke about that is plugging into the back and receiving the 10 volts from the interface module, excitating, going through the potentiometer, bringing the signal back in on the analog in. And in the software, it gives you a 0 to 1,000 count, or 0 to 10 volts equals 0 to 1,000 counts. When we did a cost comparison, what could it save our users of our product? Here's a quick overview of that. So we are reducing the inputs and output cards. So there are no more input or output cards. They're gone. The SIRIUS ACT difference is just the change in the cost for adding the PROFINET. So it does go up with the PROFINET wiring versus the classic wiring with the terminal blocks. Power supply goes down because we're not driving as much. We don't need as big a power supply. The enclosure stays the same. Labeling stays the same. Internal wiring, significantly different. We change it. And then the labor. Now this is an average of labor that we found out in the field of $62 an hour. I'm sure there's other panel shop houses that may be lower or a little higher than this, but this is just an average that we took. And then the engineering hours. Notice that it's a cut in engineering. I'm going to show you why when I switch over to the TI portal software of why that engineering hours is cut down. All right, so this is a significant cost reduction. Now, the question is maybe posed a little bit later today, or the thought may come to your mind is, where is the price break? On a panel that has, 20 buttons in here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 buttons, this would be a significant cost decrease. But let's say that you just have an e-stop and maybe 1 or 2 buttons. That's where we would look at it a little closer for the functionality and what it would save on the engineering time versus the materials just to make a 1 or 2 to 3 push button panel. Okay, so I started out in this world of doing controls, building panels. And as you can see here in this picture, this is a work of art. This takes time to get the bending radiuses right, the wire ties right, making sure all the labels are on properly, getting it all routed down, and bring it across the hinge and making sure you have a good solid mechanical set structure for it. So for the opening and closing of the panel. And this is just a work of art. And always the case is when we get this done, it has to land on IO cards. And then what I called it in the day when I there is we ring out or do a loop check to make sure that when I push this button in the top right-hand side or left-hand side, is that when I pushed it, the PLC operator saw that the contact closed or there was a contact change of state. And then he would turn on the LED to make sure the LEDs and made sure that all my wiring and everything landed in the right places and was on the right input and output addresses of the PLC. Well, here with the PROFINET push buttons, I don't need to do that. All I need to do is to test everything that is working properly is I don't need a PLC. Here's what happens is you give, once this is all wired up properly, you give it 24 volts. And then it turns on lights on the back of the modules. And if they're all solid green, everything's great. No problems. It's wired properly. And then there's no problems with the system. But for some reason, if you get a red flashing light, then that means that terminal module is not wired properly. And you need to investigate on the upstream or downstream of it. Then if you have no lights, then that means definitely there's a wire break and that there is a definite problem. And of course, it would populate to the interface module here with a flashing red light. Now, if everything's wired properly and it's working properly, but then you wanted to test the push button and make sure that it's working, you would actuate the push button, meaning push it, and that green light would start flashing to let you know that the actuation is happening. The contact closure or contact change of state is happening. This all is done with just 24 volts. No PLC involved. You don't need to have anybody come and do loop checks here. So then that panel could be set aside, knowing that everything's green lights are across the board, they're actuating, they're working properly, and then wait for the PLC guy to come out, plug in the Ethernet, and then I'll show the next step for that person in the step of the project. Here's just a quick actual picture. Here's the green lights. When the Ethernet cable is plugged in, the green light here for link would be green. Here's all the indicator lights for the terminal modules. And again, like I said, if I push that button or turn that selector switch, that green light would flash to let you know that actuation has happened. Also, if you look, see the little indicators here in the bottom left or bottom right hand or bottom right side here. The 2 slashes means that that's 2 mechanical interlocks or that's your push button. And then with the circle in the center means that it has an LED on it. Over here on the left side is notice that there's just 2 hash marks. That means it's just a contact block only. There's no LED. If it was an LED only, then all you'd see is the circle. So that kind of tells you so that you don't have to look at the part numbers of what it is. Now the ribbon cable is daisy chained. As you can see, this ribbon cable comes out, it twists, goes in here. If you notice right here at the top, real close, it's a little small, but there's an in and then there is an out to where the cable comes out, goes into an end, out, and into the end, and they're daisy chained. And then in addition, there's a little twist. You see that twist right here on that guy. Also, you remember I said there's some additional I/O on board of the interface module. So here, 1, 2, 3, 4. Here is the UV is the 10-volt power supply that you can run through the potentiometer and then bring it back in here on AI to the input or the analog input. And then this is where you're running the 24 volts. Notice that you have 2 L pluses and 2 M's. That means that you can have redundant power supplies if needed. And then here's your digital out. Here's that memory module. This comes standard with the e-stop, but does not come standard with the standard interface module. That's separately bought for that. Okay, what I'm about to show you, this is just a quick disclaimer, but this is just a program example. This is not code to send out and use. I'm just doing a quick programming example for you. So I'm going to escape out of that PowerPoint, and I'm going to come to TIA Portal. For you, if you haven't used Portal yet, this is usually opens up in this screen, and this is in the Portal view, where I could open an existing project and have them listed here. I could create one, I can migrate one, close. On the welcome tour, if you have internet connection, it will take you out. When you click on it, it'll take you out to a bunch of videos. I like these. My adage is if you don't use it, you lose it. And so sometimes when I haven't been working with something for six or 7 months, I kind of forget. And so I like these videos because they're just a quick refresher. And then knock off some of the rust if I haven't done something. And these are great refreshers, or also great tutorials for those who have never used Siemens TIA Portal. Okay, installed software. Because I've got limited time, I've already created a project and I've already put a PLC in. And I'm going to switch to Project View. And I've put in a 1517 PLC. See here, and I have actual hardware, so I'm actually hooking up to it. So what I'm going to do now is I'm going to go into Network View, and I'm going to add the interface module. So I know Siemens, and I know where everything's at. If you didn't know exactly where the part number was in the hardware catalog, you would type in right here that part number of the interface module. But because I do, I know they're under Field Devices, and they're under commanding and signaling. There's the interface module, PROFINET, and there's the two flavors. One with the yellow stripe means that it's the safety, and the other one is the standard. So I'm going to pick the standard. And then you can click on the part number, and it gives you a brief description of what the part number that you're reaching or picking. Notice that this one here has the additional digital in and digital out and analog in. If I clicked on the one above, that one doesn't have the additional I/O. And notice that the graphic of the picture of the interface module changes. This is the one I'm going to use. So I'm going to drag it into my network view. And then I'm going to drag that over here and make my internet connection. Now I have my PROFINET I/O system. And the other thing I do enjoy here in this view is to get the IP addresses. So I enjoy turning on this little icon right here, and it gives me the IP addresses. I'm going to change this guy right here, the IP address here, to 25. Okay. And then I'm going to come in here and double click on it. And there's the interface module. And now I could, if I wanted to, go out and drag and drop all the 3 different flavors of the terminal modules out there. But I think I'm going to take it a different way and go a little quicker. And this is where I said earlier about reducing engineering. I'm going to click here. I'm going to compile this. And then I'm going to download to the PLC and let it know that I'm connected to it. Start search. And I'm going to pick the PLC. Notice I have another one out there, but I'm going to pick the 1517. I'm going to load it. So now I'm letting the PLC know that I have that I have this interface module connected to it on PROFINET. It's going to just take a minute to finish loading. Now what I'm doing now is that it's setting up the PROFINET name. That's going to be the next step. And at this point is what we're showing here is once I get this connected, the link light And all these lights have already been turned on, and I've already powered up the 24 volts to my system. So now what I'm doing now is that I'm just connecting to the PLC to let it know what's going on. Back to the PLC. Okay, it's almost finished loading. Apologize for this slowness. And once this is done, it's in my project, and I'm able to do a lot of stuff with that. So now that I've got it into play, I'm going to right click, and I'm going to assign a device name. And this is the standard PROFINET name that you're going to use to call it out on PROFINET. It's going to go out and interrogate to see what systems are out there. There it is. I'm going to highlight it and assign the name. There it is. The name's been assigned. I'm going to hit close. Now, instead of, again, like I stated, I'm dragging and dropping, I'm going to right click and I'm going to say hardware detect modules from station. Oh, I apologize. I need to download the name. Got ahead of myself. I need to download to the PLC and let it know that I gave it a PROFINET name. Done that. Now I should go here, hardware detection, and it populates it. So there's all my hardware automatically populated. Once I downloaded and let the PLC know what the PROFINET name was, which is right here, I downloaded it, and then I said right click, hardware detection, modules from station, and there you are. So now let me emphasize something here real quick. This, you could come in here and change this name to console 1 or console 2. You can name whatever you want this to be. You could change this name here of that terminal module to start PB or machine off PB. You can name whatever you want this source so that you have a traceability in the diagnostics. This is not just a pretty picture for you to look at in the hardware config. These names are populated into the diagnostics of the CPU. So let's say that something happened to this terminal module. Maybe somebody opened the cabinet and they snagged that ribbon cable and cut it, or maybe dislodged the block. This guy, because you gave the name push button LED indicator, that name would populate to where you got a diagnostics from the CPU that would say PLC 1, diagnostics, console 1. That's, you change this to console 1, and then terminal module, push button, start machine. It would give that exact in language to let you know exactly where the problem is. Because this is very powerful for the Siemens's alarms. You could do an alarm on it and then and log it, and it would show you those names. There's a lot more to this, but I'm just giving you a brief overview. But now that I've populated this, I'm going to compile again. Found all the hardware. I'm going to go tell the PLC exactly all the hardware that I have. Download to it real quick. And once I finish downloading, now that I'm going to do is I'm going to go give it some tag names. Now I'm going to give the names to each of those devices. Now inside those devices, those tag names, it will be where you program it from the ladder logic or function block. Okay, almost finished. These tag names are very important because, again, it's going to be called out on your programming logic. So now, instead of calling out input 0.0 or Q 0.0, you'll actually just use the tag name for that. I apologize for it taking just a little bit long. Okay, so now that we've done that, I'm going to go here to this terminal module. I'm going to click on Properties, and I'm going to go to I/O tags. So here's that module, and I'm going to call that one PB blue underscore. Sorry about that. PB underscore blue. And then I'm going to go here, and because they're the same, notice that there's two mechanical, and that's this one and this one, so left and right. I'm going to grab this here. It's a little functionality of Excel spreadsheet, drag that down, and it called it PB_blue1. And I'm going to go to this next guy, and I'm going to go to IO tags. I'm going to call this one green. Oops, sorry. PB_green. And I'm going to grab that, drag it down, and I'm going to go to the next one. Now, these ones are just push buttons. This one is push button with an LED indicator. So now I should have an additional IO point. So I'm going to double click here, go to IO tags, and there's my additional output because this has an output for an LED. So now I'm going to grab this one. I'm going to call this red. Sorry, PB_red. Hit enter. Drag that down. And then I'm going to go here and call this red_LED. Hit enter. Okay, now again, I said this is console 1. The next thing that I would like to do, once it's filled out, if I come over here to the PLC and I tags, I want to create a default push button consoles. We'll do jump right to look at it. Add new table. Call it one. And all of them are going to go into console 1. So I'm going to do that functionality of Excel spreadsheet, drag that down, let go, say yes. And now all of them are in console 1. So I come here, and there's all my push buttons for console 1. And then I could create another one for console 2, console 3, etc., etc. All right. I wanted to show you, going back to the intensity of that LED. I could set it from 100%, 70, 40, and 10. I could also set if I wanted it to flash. So when I was programming, if I needed something to flash to really enunciate it and let the operator know what's going on, then what I would do is that I would set up some timing bit or a counter that sit there and pulse at so many hertz. And so I had to type some code for that and to tie it to that indicator light. Here, I'm going to hardwire it or parameterize that LED to that every time it gets turned on, that I want it to flash at 2 hertz. Then also I can do, and this can be done at each of those contactors, is that I could change one from a normally open to a normally close and make that hard-coded for that way. With this guy. This is very, very powerful. And as I said in that spreadsheet, that we are reducing engineering. Well, what we just did, changing the intensity of the light maybe, or changing the flashing, we just reduced some code that your PLC guy had to do for, let's say, 15 or 20 push buttons. He didn't have to go in and create new code for that. All he had to do is select the parameter of that LED module to flash. Now, a customer of mine asked me, he said, Mark, if we use the brightness at nighttime, I only want it at 40%, but then during the day, I want it at 100%. How would I do that? Because I'm trying to save my operator's night vision. He's out on a crane somewhere and it's dark, and I want to save his night vision. How would we do that? Well, there's some programming that would take in what we call data sets, to where you would read and write a data set to this push button to change that brightness. Yes, it's hard-coded here, but if we did a read-write data set, that would automatically change it via software. So it wouldn't be hard-coded that way. This is very, very powerful. Now I'm going to switch to the interface module. Now it's different for doing the tags for the terminal module. The tags are over here. If you click on the interface module and you come here to properties, then you come into IO tags, and that's where it's done here. And you remember that there is the inputs for the two contactors. So my interface module is the selector switch _1, and then the second contactor. Then I said that they had additional inputs, so I'm going to call this one, because I have it wired up to a PB _blue, and whoops, blue _1. And then this next one, whoops, sorry, we already have that tag made. So I'm going to call this one 3. Then the next one's going to be green whoops, sorry about that. PB _green _3. And then this one's going to be output is red, or input. I'm not using that. Oh, yes, I am. I'm using that as a key switch. _ selector switch. And this one is the same thing. _ _1. And then it also has an output. This is the output for the interface module. So my selector switch, I want to have that LED to turn on. So it's selector switch _LED. And then I have that additional hardwired IO, and that one's going to be red _LED _2. And then that one's done. All right, now the analog output, I'm going to click on it. Go to properties. And this one I'm going to call POT, P-O-T. So it's a potentiometer. All right. Okay, now I'm going to compile that and download that real fast. We're putting all the tags and everything in. Hit load. And we're done. Now I'm going to demonstrate that analog input module to you real quick. And I apologize for this taking long. What I've done now is, because I've given it the name of the analog input as potentiometer, what I'm going to do is I'm going to create a watch table, and I want to just show you how convenient this is to reduce the engineering time with this potentiometer. If you were a programmer, you know what I mean by 32767. That means that's if I had a 0 to 10 volt or coming in, I would go 0 for 0 volts, and then for 10 volts it'd be 32767, and then that'd be 100%, or the 10 volts. And then for 50% of that 10 volts or 5 volts, then it'd be half of 32767, which is 15 da 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 da. So what I'm going to do is show you that this is already scaled. That analog input is scaled already for you. So I'm going to come here, go to a watch table, add a new one, and I'm going to put in pot. Okay, and it's an input word 1, and I'm going to go turn that on, and I'm going to monitor that. Notice that it's at 0, and now I'm going to turn. Oh, I apologize. I have a small problem. I need to close that out. And I need to compile. Sorry about that. Go offline. And with that potentiometer, whoops, I'm not doing a force table, watch table. I have a small problem. I apologize. I'm running out of time. But you would see this monitoring value going from 0 to 1,000 counts. And so with that 1,000 counts, that means that you're able to not have to worry about scaling it and going into the program and going into the software and doing a scaling block for that. So you're going, instead of doing a scale, then you wouldn't need to do this to go in and scale that from 0 to 100 and then do the output for it. It's already done for you in the interface module of the PLC's PROFINET push buttons. Well, I'm running out of time because we've given us allotted about 30 minutes, and I apologize for that error. I think I just need to download it again. Please reach out to me. Let me quickly show you this. We have a interface, or I apologize, we have a starter kit for this system. We have the standard interface module starter kit. It comes with scissors, a screwdriver, ribbon cable, and these actuators as you see here. And then we have a safety starter kit with an e-stop, so forth. Remember that this one has to be with a safety PLC. And I appreciate your time and thank you for attending so quickly. If you have any further questions, please reach out to your local EandM personnel.